of oximes. So let's start with our preparation, that is reduction. But a question arises as to what is reduction. It is nothing but addition of hydrogen and removal of oxygen. Again, what we are doing in this method is we are reducing an oxime. But there are various different methods by which you can obtain an amine using reduction. First, let us see this. Reduction of oximes give us amine. Reduction of alkyl cyanide gives us amine. Or reduction of nitro compound gives us amine. And finally, the last one, that is reaction or reduction of amides gives us a amino group. Firstly, we would start with reduction of oximes. But the question arises over here, what is oxime? Oximes are nothing but the compounds in which there is double bond NOH as a functional group. So, next question arising, how are oximes prepared? They are prepared by the reactions of aldehyde or ketones with hydroxylamine. We have learned this in the chapter of aldehydes and ketones. So, whenever we would have an aldehyde or a ketone reacting with an hydroxylamine, we would get an oxime. So let's take an aldehyde. An aldehyde is RC double bond OH. If this is treated with N, that is hydroxylamine, that is NH2OH, what would happen? Now, H2 and O would combine, giving us a water molecule, and therefore we would just write as minus H2O. And now, what we are remaining with is nothing but RCH with a double bond. But this double bond is now connected to nitrogen, that is NOH. Again, do you have double bond NOH as a functional group? Yes, we do have it. That means, is it an oxime? Yes, it is. But was it obtained from an aldehyde? Yes, it was. So we also have an aldehyde group, and therefore the name becomes aldoxime. Similarly, let's try and take a ketone molecule, that is RC double bond O R dash. Again, we are treating it with the same molecule, that is NH2OH, hydroxylamine. What would happen? Once again, double bond O, that is oxygen and hydrogen, would combine, giving us a water molecule. What we are remaining with is nothing but R C double bond O R dash. But now, this double bond would be combining with NOH. So again, is double bond NOH a functional group? Yes, it is. So is it an oxime? Yes. But was it obtained from ketone? Yes. Therefore, it would be called as ketoxime. So, these are nothing but the two processes, that is aldoxime and ketoxime. Now, once we get a aldoxime or a ketoxime, the main point of differentiation is, in aldoxime you have RCH, whereas in ketoxime you have RCR dash. That is, H is replaced by an alkyl group. Let's move further. We still have not prepared amines, if you remember. Let's try and now see the entire reaction. We have an aldoxime, that means a aldehydic group, wherein we have double bond NOH. So we get an aldoxime. This aldoxime is now treated with sodium and ethyl alcohol. But sodium and ethyl alcohol, I remember, this is nothing but a reducing agent, and the reaction of this would be something like this. That is 2Na plus C2H5OH gives 2NaOC2H5 plus 2 nascent hydrogen. So what we would do, we would take that nascent hydrogen, that is 2 nascent hydrogen right now. What we get, let's see. Both the hydrogens are added across N and OH bond. So what you would get, we would get a compound, that is RCH single bond, but now water molecule would first be removed. So let's take the example for this. We would get RCH with a single bond and double bond NH. Now this group is called as an imine group. Again, if this imine group is further reduced using the same reducing agent, that is sodium anethyl alcohol, what do we get? Double bond would be broken down. Double bond, across the double bond you would add hydrogen, so you will get RCH2 NH2. And is this an amine? Yes, it is. So what exactly we are getting? We are getting a primary amine. Finally, the last point to remember over here is, instead of using Na-anethyl alcohol, we can also carry out this reaction in the presence of LiAlH4 as a reducing agent. This was all for this module, students. Meet you in the next module. Till then, thank you.